Good morning, everyone. In the last class, we had discussed about the preparation of alcohols and phenols, right? And about the physical properties of alcohols and phenols. So, among these different methods of preparation of phenols, can you tell me any one method, Vidur?
From halogens.
From?
Halogens.
Yeah. Which reagent is used?
Chlorobenzene.
Chlorobenzene, that is haloarine, right? It's reacted with?
Sodium hydroxide at 623 Kelvin.
Then which ion is formed?
Sodium phenoxide.
Sodium phenoxide ion. Then it is converted to phenol and acidification, right? Okay, then what does this Q mean? Aditya, what does this Q mean?
Ma'am, isopropyl benzene.
Yeah, isopropyl benzene. It is otherwise known as cumene. Then what about the boiling point of alcohols and phenols? Comparing to other class of compounds with same molecular mass, Dia? Yeah, higher boiling point to this alcohol and phenol compared to other class of compounds, right? What's the reason for that? Achyut, can you tell me the reason for the higher boiling point in alcohols and phenols? Achyut? Yeah.
Intermolecular hydrogen bond.
Yes, due to intermolecular hydrogen bonding. Okay, so we have completed the preparation and the physical properties. Today we are going to learn about the chemical reactions. Okay, chemical reactions. All of you, please switch on your videos. Rijas, Emmanuel, Nia, Anna, Shivani, Mehak. Okay, so we are moving to the chemical reactions. So in the case of this alcohols, they are versatile compounds. Alcohols are versatile compounds. What's the meaning of the term versatile? Versatile. They can be exist in different forms. Okay, alcohols, they are versatile compounds. That means they can exist in different forms. Here in the case of reactions, alcohols can act both as a nucleophile and electrophile. Okay, alcohols can act as both electrophile and nucleophile. In the case of electrophile, they were always electron loving. Electrophile, electron loving, nucleophile, nucleus loving. Okay, so now we are going to learn how this alcohol acts as nucleophile and how this protonated alcohol acts as electrophile. So first one, alcohol acts as nucleophile. Nucleophile means they are always nucleus loving or positive charge loving. Positive charge loving. Then here you can see this one is alcohol, right? ROH. ROH, it stands for alcohol. So here in this oxygen, this is the nucleophilic site. Okay, it's the nucleophilic site. That means excess electrons are present in oxygen. That's why they are searching for positive charge. And this ROH group, oxygen, that has excess electrons. You can see here lone pair of electrons present in oxygen atom, right? So this oxygen atom, it will accept or it will attack the positive center of this alkyl group. Here you can see one positive charge on carbon, right? That means it's a carbocation. Oxygen, it has lone pairs. That means it's always electron rich, right? Electron rich. That's why they are searching for electron deficient species. And this carbocation, it's a electron deficient species. So this oxygen in the alcohol group, it will attack on the positive charge of carbon. And the second product form is just the combination of the two reactants in the first step. Okay, this carbon, it is attached to this oxygen. Clear? The oxygen, it is attached to the positively charged carbon. That means a carbocation. Then this carbon is joined to this oxygen. That is the second step. And in the case of this nucleophile, when alcohol acts as nucleophile, always the bond breaking take place between this oxygen and hydrogen. Okay, the bond breaks between oxygen and hydrogen. That means cleavage of OH bond take place. So you can write there cleavage of OH bond take place. Okay, cleavage of OH bond take place. Here in the final product, this hydrogen is removed from oxygen. Right? So this is the type of chemical reaction take place when alcohol acts as nucleophile. When this alcohol acts as nucleophile, you have to remember it is electron-rich species and it was always searching for a electron-deficient species. And this carbocation, it's an electron-deficient species. So oxygen present in this alcohol, it will attack on the positively charged carbon of carbocation. And this carbon is joined to oxygen atom. Okay, then the cleavage of OH bond take place. That means hydrogen will be removed from this compound. So this is the case of reactions where alcohol acts as nucleophile. Is this clear about the first one? Is this clear?
Yes, ma'am.
All of you. Gauri, is this clear for you? No. Okay, I will draw this figure. Just wait. ROH. Okay, this is one alcohol, right? Alcohol. Then this oxygen contains lone pair of electrons. Lone pair of electrons means the electrons that not involved in any bonding. Okay, so this alcohol will act as a nucleophile. Nucleophile means they are electron rich and they are searching for positive charge. And this alcohol, it will react with one carbocation. Okay, carbocation. So this oxygen atom, it will attack to this carbon. And in the second step, just the joining of this carbon group take place. This is the second step. Clear? Okay. Then in the final step, the cleavage of OH bond take place. That means ROC. This is the bond formed here. Here is one positive charge. Okay. When this one is attached to here, there is one positive charge in oxygen. Yes. So this hydrogen will be removed from here and this one is the final product obtained along with H plus. One hydrogen will be removed. Clear now? Yes. Okay. All of you please switch on your videos. Srihari, Adul, Meenakshi, Malavika, Evelyn, Nia, Shivani, Naurin, Anna. Yes. This is clear, children. Shall I move to next one? Any doubt? Anyone? Nothing, right?
Ma'am,
Yeah.
can you explain only how hydrogen is coming out? So,
Hydrogen
like how hydrogen gets separated and becomes
separated, right? In the case of this oxygen atom, here there is one positive charge and one bond is in excess. So some cleavage occurs between any of these atoms. So always in the case of reactions in which alcohol acts as a nucleophile, OH bond will break. So the coming reactions in which this alcohol acts as a nucleophile, always OH bond will break. That means hydrogen will be removed from the. Clear? All of you?
Yes.
Yes. Then we are moving to the next one. That is protonated alcohol acts as electrophile. I told you about this alcohol. It's a versatile compound. That means it can act as both electrophile and nucleophile. So first case, that's about nucleophile. Second one, electrophile. But in the case of electrophile, Protonated alcohol can act as electrophile. What is this protonated alcohol? Protonated alcohol means one H plus ion is added to alcohol. That is protonated alcohol. So here the first step is that RCH2OH, that's one alcohol, right? Then H plus ion is added. H plus ion is added. Then it will become RCH2OH2 plus. This one is protonated alcohol. One proton is added to alcohol, that is protonated alcohol. Okay, protonated alcohol. And this protonated alcohol will act as a electrophile. Electrophile means they are always electron loving or negative charge loving. Then you look at the second step. So RCH2OH2 plus, RCH2OH2 plus. This is the protonated alcohol. It will react with Br minus. This one is a electrophile. So Br minus, it's a nucleophile, right? Isn't it? When protonated alcohol acts as a electrophile, this Br minus, this one is a nucleophile. That means they are electron-rich species and they will join with a positively charged center. So here, this Br minus, it will be attached to carbon, not to oxygen, here to carbon. Okay, in the previous case, the carbon will be attached to oxygen because it will attack the nucleophilic site. Here it will attack the electrophilic site. So this Br minus, it will be attached to CH2, the carbon here in the alcohol. So when one more bond is attached to carbon, this OH2 bond, it's 5 bonds are formed between here, right? When one more Br minus is attached to carbon, you can count here already 2 hydrogen atoms, then 1 R group, then Br minus, 4 groups. Then OH2, again it will be 5. So it is an unstable compound. So to remove one compound from here, this H2O plus will be removed. That means the CO bond cleavage take place. CO bond. In the previous case, OH bond cleavage take place, and here CO bond cleavage take place. Clear, children? I will draw it again in the board. Just wait. RCH2OH. This is an example for one alcohol. Okay, RCH2OH. Then one proton is added to here. It will become RCH2OH2 plus, right? This one is known as protonated alcohol. Protonated alcohol. Okay, and this protonated alcohol, it's a electrophile. Protonated alcohol is a electrophile. That means they are positively charged and they need negative charge. So this Br minus will be react with this protonated alcohol. Okay, and here the electrophilic site, that is carbon. So Br minus will attack to carbon. You can see here already R, then 2 hydrogen and OH bonds there. Then when Br minus is again attacked to carbon, the valency of carbon will be 5. It's an unstable state. So this OH2, it will be removed from here. Then it will become RCH2 Br plus H2O. Yeah, H2O. This is clear now?
Yes, ma'am.
All of you? So here you have to remember CO bond cleavage occurs. Okay, the bond between carbon and oxygen will break. In the previous case, OH bond cleavage occurs. So based on this cleavage, the following reactions will take place. Clear, children? Any doubt? Anyone? Emmanuel, any doubt? Yeah, sure. First case, alcohol will react with proton and protonated alcohol formed. Okay, protonated alcohol means one H plus ion is added to alcohol. That's it. And this protonated alcohol is an electrophile. Electrophile means they have electrons and they need protons. Okay. So here, electrophile means they are positively charged and they need electrons. Okay, same thing. Okay. So here it will be reacted with Br minus. It will react with Br minus, and this Br minus will attack here in the carbon. Okay, carbon, because it is the electrophilic site. That's why. So this Br minus will attack to carbon. The bond situated around the carbon, it will become already 2 hydrogen atoms, then one R group and one OH group, right? OH2 group. Then again this Br minus will join to this carbon, its valency become 5. It's an unstable state, right? So one group will be removed from here. So this H2O group, it will be removed from this carbon. That means the bond between carbon and oxygen breaks. Clear? So these are the two cases in which alcohol acts as both electrophile and nucleophile. So in the first one, when alcohol acts as nucleophile, OH bond breaks occurs, and protonated alcohol acts as electrophile, CO cleavage, CO bond breaks. This is clear, children? Shall I move to next one?
Yes, ma'am.
Okay. So based on these two electrophilic and nucleophilic nature, chemical reactivity of alcohols can be classified in the following way. First one, reactions involving the cleavage of OH bond. OH bond, that's related to nucleophile, when alcohol acts as nucleophile. Then the second one, reactions involving the cleavage of CO bond. That's in which protonated alcohol acts as electrophile. Switch on your videos, children. Have you completed this one? Anna, Adul, Naurin, Shivani, Evelyn, Srihari, Malavika, Gayatri, Michael, Aryan, Punya, Krishna, Donna. Switch on your videos. Shall I move to the next slide?
Yes, ma'am.
So first we are going to learn the reactions involving the cleavage of OH bond. Okay, reactions involving the cleavage of OH bond. So in all these reactions, the OH bond will breaks. Okay, OH bond will breaks. First one is acidity of alcohols and phenols. Acidity of alcohols and phenols. In the section, first we will deal with the reaction with metals. Reaction with metals. So here, alcohols and phenols will react with active metals. Active metals like sodium, potassium, etc. to form alkoxide or phenoxide. Okay. Here, alcohols and phenols, it will react with active metals such as sodium and potassium to form alkoxide or phenoxide. Okay. So the first example, you look at the first one, 2ROH. This is an example for alcohol, right? 2ROH. And it will react with an alkali metal Na. Na. So 2ROH reacts with 2Na to form its sodium alkoxide. Instead of H, you know that here the cleavage of OH bond occurs, right? So this oxygen hydrogen bond will break and this Na will attach to this position. So these are the reactions involving the cleavage of OH bond. So here the OH bond will break and this hydrogen will be removed from alcohol and sodium will replace this position. And sodium alkoxide is formed. Clear? I will repeat it once again. Alcohols and phenols, it will react with active metals such as sodium, potassium, then aluminium, etc. to form alkoxides or phenoxide. If alcohol is reacted with sodium metal, alkoxide will be formed. If phenol is reacted with active metals, phenoxide is formed. Here it's a simple reaction, just the bond between oxygen and hydrogen breaks and sodium will be attached. Okay, clear? So here alcohol will act as a nucleophile. That's the reason why the cleavage of OH bond occurs. Clear? This is clear, children? Yes. Then second one is next example. Here instead of R groups, we will write tertiary butyl groups. Carbon with 3 methyl groups. That is tertiary butyl. Then the same thing occurs here. The cleavage between OH occurs. Okay, here the metal used is aluminium. So instead of sodium, here aluminium will be there. No other change in the reaction. Clear? 6 tertiary butyl alcohol react with aluminium and the cleavage between oxygen and hydrogen take place. And here it is aluminium tertiary butoxide will be formed. So instead of hydrogen, aluminium will replace this position. Okay. So these are the two examples for alcohol. When alcohol react with active metals like sodium, potassium, aluminium, etc. This is clear, children? Yes. Then we are moving to phenol. Here also same thing occurs. Instead of alkoxide, phenoxide will be obtained. Here also the cleavage of OH bond occurs and Na will replace that position. Then it will be known as sodium phenoxide. Sodium phenoxide. The same product will be occurred. Instead of Na, we can use NaOH. Okay. The same reaction, instead of metal, we can use metal hydroxide. That is sodium hydroxide. Sodium phenoxide will be the product. So when alcohols and phenols react with active metals, alkoxides or phenoxides will be obtained. The formation of this alkoxide and phenoxide, it is due to the cleavage of OH bond. Only the bond breaks between oxygen and hydrogen. This is clear? Any doubt, children? Switch on your videos. Anna, is this clear?
Yes, ma'am.
Okay. Rijas? Okay. So that's about the reaction of alcohols and phenols with metals. Only you have to remember the cleavage of OH bond occurs when alcohol acts as nucleophiles. That's it. Okay. So hydrogen. Yeah, sure.
Can you explain why it is called third butyl alcohol?
Tertiary butyl, right? Because this one is tertiary group. Carbon with 3 substituents. Carbon with 3 alkyl groups. This one is tertiary. So here carbon is surrounded with 3 methyl groups. That's why it's tertiary butoxide. Clear? Yes. Then this alcohols, and here we are discussing the acidity of alcohols and phenols. Okay, acidity of alcohols and phenols. So from this reactions, we are confirming the alcohols and phenols are acidic in nature. That means they will donate H plus ions in the previous reaction, right? One hydrogen will be removed from the reaction. That means they are donating H plus ions. We are always considering the acidic nature of substances by the donation of H plus ions, right? How can we confirm the acidic character? Substances that can able to donate H plus ions, they are considered as acids, right? Isn't it? Yes. So in this reaction, you can see that all this alcohol and phenol, they are removing H plus ion. That means they are donating H plus ion. So from this reactions, we can confirm alcohols and phenols are acidic in nature. Alcohols and phenols are acidic in nature. This alcohols and phenols, they are known as Bronsted acids. Bronsted acids, that is, they can donate a proton to strong base. Okay. If the substance can able to donate H plus ion, they are known as Bronsted acids. So here this alcohol and phenol is considered as Bronsted acids. Then here the reaction take place there between one acid and a base. ROH, that's the representation of acid, right? Then one base is reacting with this acid. This H plus ion is removed from this acid towards the base, or they will donate H plus ion to a base. Clear, children? When an acid reacts with base, it will donate, this acid will donate H plus ions to base. That's why they are known as Bronsted acids. And after the removal of hydrogen from this acid, it will be known as a conjugate base. When, yeah.
Can you tell the point again of Bronsted acid?
Yeah, the substances that can able to donate protons, they are known as Bronsted acids. That's it. Same thing similar to that of acids. Acids also donate H plus ions. Just remember the conduction of electricity of acids. Do you remember? They can able to produce electricity because they can able to produce H plus ions. Isn't it? So the all acids can able to produce H plus ions. Here in the case of alcohols and phenols, they will donate H plus ions. That's why they are known as Bronsted acids. Clear? Bronsted acids. And you look at this reaction. ROH, that's the representation of alcohol. Okay, this one is one alcohol, and here it is act as acid because they are donating H plus ions to base. Okay, they are donating H plus ions to base. When this acid will donate H plus ion, the remaining portion is known as conjugate base. Conjugate base. When an acid donates H plus ion, the remaining portion, here it is RO minus. It one is known as conjugate base. Conjugate base. And the base will receive that H plus ion and it will known as conjugate acid. Conjugate acid. I'm repeating the points once again. When this alcohols and phenols react with metals, hydrogen H plus ions will be removed from that substance. That means they are donating H plus ions. So due to this nature, this alcohols and phenols are considered as acidic. Okay, and here this is the reaction to explain their acidic nature. Acidic nature. When this acid will react with base, acid will donate H plus ion. That's why they are known as Bronsted acids. And the remaining portion of acid without H plus ion is known as conjugate base. And when this base will accept this H plus ion and it will become conjugate acid. Conjugate means the remaining portion of, you have to remember like this. When this acid donates H plus ion, the remaining portion will be considered as conjugate base. Okay. And when this base will accept one proton, then it will become conjugate acid. Clear?
Ma'am, is it a negative symbol on top of B?
Yes, base. Here, it's just when you consider this base, Na, OH. We will write Na plus and OH minus ion, right? Similarly, here to represent this OH minus ion, it will be considered a negative charge on base. Clear? Yes. This is clear, children, about this Bronsted acids. Any doubt? Clear, right? Dia, this is clear for you?
Yes, ma'am.
Yes. Punya? This is clear? Yes. Okay. Then we are moving to the acidity of alcohols. How this acidity of alcohols is varied in each case. So we know that this acidic character of alcohol, it is due to the polar nature of OH bond. Along with, they can able to donate H plus ions. This polar nature of OH bond is also considered. Polar nature means if two atoms have large difference in their electronegativities, they will become partially positive and partially negative, right? Here this oxygen atom, it is an electronegative atom, and hydrogen, it is electropositive. So this oxygen atom have a tendency to withdraw electrons from this shared pair, and this hydrogen will get a partial positive charge and this oxygen will get a partial negative charge. So here the acidic character of alcohols, it is due to the polar nature of OH bond. Polar nature of OH bond. And when we are considering the primary, secondary and tertiary groups of alcohol, primary group contain only one alkyl group to which the carbon is attached. Then secondary groups, 2 alkyl groups, tertiary groups, 3 alkyl groups. The number of alkyl groups is increasing from primary, secondary towards tertiary. Okay, that means more substituent will be in the carbon. Carbon to which OH group is attached. In the first case, this is the carbon to which OH group is attached. Only one other substituent, right? It is considered as primary. In the secondary carbon atom, the carbon to which OH group is attached contains 2 alkyl groups. It is considered as secondary. Okay. Then the third one, the carbon to which OH group is attached, it contains 3 more alkyl groups. It is considered as tertiary. So in the case of this primary, secondary and tertiary alcohol groups, the increasing electron releasing groups, here the electron releasing groups are alkyl groups. Okay, alkyl groups. Increasing electron releasing groups increases electron density on oxygen. Okay, if there are more alkyl groups in the same carbon atom, it will increases the electron density on oxygen. Electron density on oxygen. And it will decreases the polarity of OH bond and hence acidity decreases. That's why here the primary has more acidic character compared to secondary and tertiary. I will repeat the point once again. If the electron releasing groups increases. Electron releasing groups are the alkyl groups, R groups. R groups are the electron releasing groups. Their duty to release electrons to the chain. Okay. So when this electron releasing groups increases, the electron density on oxygen also increases. Electron density on oxygen increases. And here it will decreases the polarity of OH bond. And it will decrease the acidity also. Clear, children? If more alkyl groups are present, they will release more electrons to the chain and they will decreases the polarity of OH bond and the acidity decreases. So the primary alcohol group has more acidic character compared to secondary and tertiary. Clear? So that's about the variation of acidity in the case of primary, secondary and tertiary alcohols. Always in primary alcohol, more acidic character compared to secondary and tertiary. The reason is that when the electron releasing groups increases, they will increases the electron density and decreases the polarity of OH bond. Clear? This is clear? Okay. Emmanuel, can you please read the points?
Acidic character of alcohols is due to the polar nature of OH bond. Increasing electron releasing groups increases electron density on oxygen and decreases the polarity of OH bond, and hence acidity decrease.
Okay. Hence acidity decreases. Shall I move to next slide? Yes.
Yes, ma'am.
Yes, right? Okay. Then when we are comparing this acidic nature of alcohol with water, okay, alcohol with water, we learned that this alcohols and phenols, they are acidic in nature. They are act as Bronsted acids, right? They can able to donate H plus ions. But here, when we are comparing the acidity of alcohol with water, alcohols are weaker acids than water. We already learned alcohols and phenols are acidic in nature. They act as Bronsted acids because they will donate H plus ions. But when they are reacting with water, they act as a weaker acids than water. That means they will act as a base here. Clear? The previous section, we learned that alcohols and phenols, they are acidic in nature. They will donate H plus ions. That's why they are known as Bronsted acids. But when they react with water, it will become weaker acids. Weaker acids mean they will act as a base compared to water. So in this reaction, you can see here, acid is water, right? Water is considered as acid, and this alcohol group that is represented as RO minus, it will act as a base, RO minus. Then it will accept one hydrogen from this water and it will become ROH. ROH. And water molecule, it will donate H plus ion and it will become OH minus. So the base, it will converted to a conjugate acid and this acid is converted to a conjugate base. It's just opposite to that of the previous reaction. In the previous reaction, both alcohols and phenols will donate H plus ion and they are act as a Bronsted acids. But when it comes to the reaction with water, they will act as a base. That means water is more acidic than this alcohol and phenol. So water will donate H plus ions to this alcohol. Okay, clear? So water is a better proton donor than alcohol. When we are comparing the acidic nature of alcohols and water, here water is a better proton donor than alcohol. That's why it is considered as a acid. Alkoxide ion is better proton acceptor than hydroxide ion. Alkoxide ion means when we remove hydrogen from this alcohol, it is known as alkoxide ion. This RO minus ion is known as alkoxide ion, RO minus. When hydrogen is removed from this alcohol, it is known as alkoxide ion. So alkoxide ion is better proton acceptor than hydroxide ion. So they will accept electron from water. Then alkoxides are stronger bases. Here they will act as a base. Comparing to the water, this alcohol acts as a base because they are accepting protons here. In the previous case, they are donating electrons, right? Here they are accepting electrons. So alkoxides are stronger bases. Here alcohols act as Bronsted bases. It is due to the presence of unshared electron pairs on oxygen. Here in the base section, you can see that RO minus. Oxygen is surrounded by lone pair of electrons, right? They are known as unshared electron pairs. So alcohols, they are act as Bronsted bases. It is due to the presence of unshared electron pairs on oxygen. Unshared electron pairs on oxygen. Clear, children? So in the case of alcohol, they can act as both Bronsted acid and Bronsted bases. Okay. In the case of water, they will act as Bronsted base because this water is a better proton donor than alcohol. So this alkoxide ion, it will accept this protons from alcohol and act as a Bronsted base. And it happens, it is due to the presence of unshared electron pairs present on oxygen atom. And here also the same thing, when the acid will donate H plus ion, it will act as a conjugate base. Okay, here the water will donate H plus ion and the remaining portion, that is conjugate base. And the base here is alcohol, it will accept one hydrogen and it will become conjugate acid. Okay, this is clear? Yeah, sure.
Can you say again?
Yeah, sure. In the case of this alcohols, they can both act as Bronsted acid and Bronsted base. You have to remember this point. Okay. In the previous reaction means this one. Here you can see that this alcohol group, they will donate one H plus ion to the base and they will act as a Bronsted acid. Isn't it? Yes. And in this case, when they are reacting with water, they will act as a Bronsted base because this water molecule, it's a better proton donor than alcohol. This water molecule will donate H plus ion and this base is alkoxide ion. They will accept this hydrogen, H plus ion. This is clear now? Achut? Yes, right. Okay. Yeah, then the next one is acidity of phenol that we can discuss in the next class. The class is till 11:50, right? Okay, then acidity of phenols we can discuss in the next class. So today we have learned about the reactions of alcohols and phenols, right? Reactions of alcohols and phenols. All of you, please switch on your videos. Yes, Naurin, Dona, Punya, Adul, Shivani, all of you. So in this reactions of alcohols and phenols, this alcohol and phenol, they can act as both electrophile and nucleophile. So when they will act as nucleophile, they act as a, that means cleavage of OH bond occurs. Then when they act as an electrophile, cleavage of CO bond occurs. First, we are dealing with the reactions involving the cleavage of OH bond. First one is reaction with metals. When they will react with metal, alkoxide or phenoxide ion is formed. Then we are moving to the acidity. This alcohols and phenols, they are acidic in nature because they are donating H plus ions. Okay, then that's why they are known as Bronsted acids. But when they are reacting with water, they will accept this hydrogen H plus ion from water. That's why they are known as Bronsted bases. Okay, then when we are comparing the reactivity of primary, secondary and tertiary alcohols, primary alcohol is more acidic in nature because when the electron releasing groups increases, their acidic nature decreases because it will increases the electron density and decreases the polarity of OH bond. Clear, children? Then we can discuss the remaining portion in the next class. Let me take your attendance. Just wait.